Write a recurrence relation and recursive program for factorial n. So, program for factorial n. So, how we can write? We can write a program like this: function int n, and if n is less than equals to 1, then return 1, else return n into factorial n minus 1. So in that way we can write a program for factorial n. So as we know, it is recursive in nature also because function calling itself, as we have seen in the last lecture also. So the recurrence relation can be written like this: fn is equals to n into fn minus 1 if n greater than 1, and the value will be 1 if n is less than equals to 1. So in that way we can write the recurrence relation, and this is the way we can write the recursive program. So how basically it works, as we know, take lots of space for stack. How, suppose we are calculating the factorial 5, so first we will go 5 into factorial 4, then it will take 4 into factorial 3, then 3 into factorial 2, then 2 into factorial 1, and then return 1. So how it work? So first from here 5 into factorial 4, then it will go to factorial 4, then factorial 4, so it will go, because we need to calculate factorial 3, so it will go factorial 3, then after that where it will go to factorial 2, to calculation of factorial 2. Now again it will go to factorial 1, then at the end it will go to the return 1, and after return 1 it will get the factorial 1 value. So it will go like this: here it will get factorial 1 value, then factorial 2 value, then factorial 3 value, then factorial 4 value, and at the end it will get factorial 5 value. So in that way it is calling itself, so it is taking lots of space. It will go like this. So we can say this is the main program, and after calculating every factorial it will reach to the same place. Here at the end it will reach the same place where it started its journey. From here it started its journey, because suppose we are calculating factorial 5, that's why. So for factorial 5 we need factorial 4, and factorial 4 we need factorial 3, for factorial 3 we need factorial 2, for factorial 2 we need factorial 1, and at the end it will take 1 value, because when n is less than 1, then 1. Then after this it will get factorial 1, then we reach to factorial 2, then factorial 3, then factorial 4, and then factorial 5. So at the end it will return the same place from where we started our journey. So we can see clearly that it is calling itself. So this is the way of the recursion, the function calling itself. So in that way we can write, that's why we can write the recurrence relation like this: n into fn minus 1 if n value is greater than 1, and 1 when n is less than equals to 1. So this is also the program for factorial n. Function integer n we have taken: if n is less than 1, then it will return 1, else it will return n into fn minus 1. So in the similar way, we write a recurrence relation and recursive program to multiply two positive numbers. Multiply two positive numbers. Suppose we are taking m and n. So how we are going to write a recurrence relation? For that, we can write like this: multiply mn is equals to 0 if m is equals to 0 or n is equals to 0, and m plus multiply m n minus 1 otherwise. M plus multiply m n minus 1 otherwise. So in that way we can write the recurrence relation. So how it going to work? Suppose we are taking m and n value like this: multiply 3, 5. This is m, this is n. So how it going to work? Going to work like this: 3 plus multiply 3, 4, m multiply m n minus 1. Like this it will go. So next what will happen? 3 plus multiply 3 into 3. Then what next? Then we write like this. So after that what we will get? We will get 3 plus multiply 3, 2. Then after that what we will get? We will get 3 plus multiply 3, 1. Then after that what we will get? 3 plus multiply 3, 0. So like that it will go. So how many time it will run? It will run 5 time. Here it will run 5 time: 1, 2, 3, 4 and 5. So we can say order of 5, order of n time it run. So we can say order of n, because as we have seen 1, 2, 3, 4, 5 times it runs. So we can say order of n. So this is if we change m to n. So here if we change m to n, so the order will get decreased. So if we change m to n, so order will get decreased. If we write like this: multiply 5 into 3, so it will take less time and the order will get changed. From order of 5 it will reduce to order of n. So here the order of n will be 3, but here order of n is equals to 5. So we can say this is the worst case and this is the best case. By changing the order we can just change the all these things, all the scenario. So how we can write a program for this multiplication? We can write like this: multiply int n comma int m, not m, n, multiply int m int n, and if m equals to 0 or n equals to 0, then return multiply int m int n. If m equals to 0 or n is equals to 0, then return 0, else else return m plus multiply m n minus 1 and closing bracket. So this is the program, and this is the recurrence relation. Multiply m n 0 if m is equals to 0 or n is equals to 0, and m plus multiply m n minus 1 otherwise. So this is the way of writing the program. Multiply int m int n if m is equals to 0 or n is equals to 0, then return 0, else return m plus multiply m n minus 1. So in that way, or from this example, we also find out what will the complexity. The complexity will be order of n time for this program.